We talk a lot about large language models on this channel, but generating text on a screen is the easiest part of AI. The hardest part, getting AI to interact with the physical world. Welcome back to Tech and Us. Today we are looking at breakthrough from the World Artificial Intelligence Conference that proves the era of typing and swiping is coming to an end. BrainCo just demonstrated a robotic arm that is controlled entirely by human thought. This isn't a science fiction concept, and it isn't restricted to medical labs anymore. It's here, it works in real time, and it is going to completely upend the hardware industry. Let's decode exactly how this works. Here is the breakdown. The BrainCo system uses a non-invasive brain-computer interface, or BCI. You wear an EEG band. EEG band is like kind of a black cap with electrodes in it that reads your neural signals. When you think about moving your hand, your brain fires specific electrical pattern. The BCI captures, BCI is brain-computer interface. The BCI captures those patterns. An AI model decodes your motor intent in milliseconds, and the robotic arm mirrors the movement perfectly. Look at the dexterity here. It's not just opening and closing a claw, it is adjusting grip strength. Like if you hold an egg, you don't press it. The robot is like, if it's holding a cup, like say this is a cup, or like this. So I can put pressure, how much pressure I can put. Robot can put pressure, it can, it can crack this thing. But holding an egg or a tomato, it has to be very gentle. Or holding a baby, for example, the claw can crush the baby brain. That's a joke. It shouldn't be. We are into tech channel. We can crack some bonehead. So look at the dexterity here. It's not opening and closing a claw. It's adjusting grip strength dynamically to hold an egg without crushing it. Like I said, the baby head, you don't crush it. This is called Neuro-Embodied-AI, connecting the human nervous system directly to physical robots. So your nerves fire signals and EEG catch those signals. Within milliseconds, the AI captures those signals into a robotic, whether it's a robotic hand movement, gesture, or whether it's happening in visual cortex like blinking an eye, which is a very reflex. Brain doesn't control it; it happens with the natural reflex. But looking here or there are some changes in the visual cortex of your front part of front lobe of the brain, and left and right hemisphere. The EEG can definitely capture it, and you can dream and you can think like it can capture those signals from the neurons, and it directly converts into an AI model that helps to visualize what part of the body is affected. If it's a physical AI like hands, definitely the neural signals AI can learn from the AI model. You can just ask them to train like various activities, putting an EEG and noting all those signals and taking data from every hospitals around the world. You can compile that data and bring a model where any physical movement of like this height, this height, this height can be turned into like neural pathways. The brain impulses can be captured into electrical signals, fed into AI model, and the AI model helps a robotic arm to do exact the similar, like to a millimeter precision. And it has also like if it's an holding an egg, so you know by camera with vision that you are holding an egg, you are holding a cup, say for example. So the AI model must have camera or or have contact sensors on this on the claw, which can tell whether it's a cup or baby or an egg, and how much pressure to put into it. So definitely, I think now it's a logical step, but I think Chinese company BrainCo has developed this technology and perfected this AI model. That's great. And it's called Neuro-Embodied-AI, new term. We should have after Neuralink, we should have a different concept and different terminology. I think Neuro-Embodied-AI is like a definition, and definitely we think we will come up with something called Vibe AI or something like that. We don't know. Let's see. So if you are an engineering student or a developer here in Bangalore, pay close attention, because it's not humanoid robot. It's 6-axis arm which are everywhere in surgery. You can find that open source code which operates. There is Seed Studio which has their own arm, and there are so many open source hardware and software which can do any axis of hand movements with their robotic arm, and it's placed on the table. You can clamp it on the table, and it can work on any surface. You just need like this. You just need, and it will do all the movements in any direction, any freedom or any degree of freedom. And I have one at my office, so I'll show you sometime. The software boom of the last decade was about web apps and SaaS, mobile apps. The $1 trillion industry of 2030 is physical AI. I'm talking about physical AI. We have Ira, a tutor that uses AI to teach kids, any kids in Singapore. AI is just the brain. Robotic is the body. If you want to future-proof your career right now, start looking into RS, the robotic operating system. Look into ecosystems like Boston Dynamics, Seed Studio, those kind of ecosystems where you can find, and GitHub, where you can find lots of projects in ROS, robotic operating system. They are open source, and you can create beautiful hardware and reinforcement learning algorithms using those hardware, and you can make humanoid robots or access robots, or like you see in my office in the background, there are some robotic hands. So you can use ROS very easily to make your own robotic hand. The engineers who figure out how to reduce the latency between a neural signal and a mechanical servo are the ones who will define the next decade of tech. It's a massive open frontier. But we can't talk about this without addressing the massive red flag, privacy. So, robot senses everything. There is LiDAR, there's mobile phone Android which can have LiDAR capabilities and can see your environment, not in visual sense, but the surroundings, what is there, and they can use AI model to predict what your surroundings look like, whether there is a computer or not, there is a vacuum cleaner or not, there is a hardware device, breadboard or not. They can easily gauge that. So if a piece of consumer hardware can read and interpret your motor intentions, who owns that data? So your brain signals has been translated into robotic hand movements, and the data passed from your brain went onto the online. It goes onto the server for AI model to predict what the movements are. So there is a data which has been generated. So who owns that data? This is privacy. What happens when a tech company knows what you want to do before you actually do it physically? It's a massive ethical dilemma, and it's something Ranjit and I are going to tear apart in our full-length podcast episode later this week. So make sure you check that out. For now, I want to know where you draw the line. Would you wear a helmet, brain reading headband to control your smart home? Or is this too invasive? Vote in the poll below and subscribe. You will see in the next one.